Hello. Today we're going to talk about the Fundamental Theorem of Calculus. So, in the Fundamental Theorem of Calculus, we're going to anti-differentiate and then we're going to plug in the two numbers that we have into the function. So, let's see an example and hopefully it will make more sense. So, we have differentiate based on 2 and 0, x squared plus 3, and then the x. So we need to anti-differentiate based on 2 and 0, x squared plus 3. And let me write the dx. Okay. So first of all, we're gonna anti-differentiate. So we have x squared. We know it should be x to the power 3. In order to get the 1x we had here, it's gonna be 1/3. Because we're gonna have 3 multiplied by 1/3 plus 3x. Because 3 becomes 3x. And now we had 2 and 0. So we're gonna put this line here, 2 at top and 0 at the bottom. So basically we can say that's f. So now the rule says that we're gonna plug into f2 minus f and plug in the 0. So we're plugging in the upper number first and then the lower number in second. So basically we're gonna have 1/3 multiplied by, instead of x we're gonna have 2 to the power 3 plus 3 multiplied by 2. I'll put it into parentheses. Then minus 1/3 multiplied by 0 to the power 3 plus 3 multiplied by 0 equals, we're gonna have 1/3 multiplied by 8 plus 6 minus, this will give us 0, this will give us 0, it's minus 0. So basically we're gonna have 8/3 plus 6, which equals 8/3 plus, an easy way to solve it would be to take 6 multiplied by 3/3, which is 1, give us 18/3. So 8/3 plus 18/3 results in 26/3. Okay, now let's look at another example. And to differentiate with 9 and 4, we have 1 plus square root of x dx. So we can rewrite it as, I'm gonna put on the differentiate 9 and 4. 1 gonna stay the same, but instead of square root of x, we can write x to the power of half and dx. It's gonna make it easier to differentiate. So we're gonna have, instead of 1, it's gonna become x plus, we can write the x, 1/2 is gonna increase by 1, so it's gonna be 3/2. In order to get 1x, we're gonna multiply by 2/3. We're just gonna switch it, and then I'm gonna write this line here, 9 as we add, and 4. Write this is 4. So based on that, we're gonna have f of 9 minus f of 4. So we're gonna have 9 plus 2/3 multiplied by 9 to the power of 3/2. And all of that will be minus 4 plus 2/3 multiplied by 4 to the power of 3/2. So you guys can use calculator in order to solve it. 9 plus 2/3 multiplied by 27 minus 4 plus 2/3 multiplied by 8 equals 9 plus 18 minus 4 minus 16 thirds, which basically equals 23 minus 16 over 3. So we can rewrite it as 23. So we're gonna have 3 over 3 multiplied by 23, which results in 69 over 3. So we're gonna have 69 over 3 minus 16 over 3 equals 53 over 3. And that would be the final answer. That was the final answer here. Let's look at another example. Anti-differentiate based on 2 and 1. We're gonna have x multiplied by x squared plus 3 and to the power of 4 dx. So in order to anti-differentiate that, we're gonna have, we know we can rewrite the inside, the power gonna become 5, 4 plus 1 gonna become bigger by 1. Now in order to find the number here, we know that in order to derive, we multiply the power by the derivative of the inside. So we're gonna have 2x, and that's gonna be multiplied by something in order to get x here, so it would need to be equal x. So we have 10x multiplied by something to get an x. So basically it would be 1/10. So we can put here 1/10. That's a trick that I do in order to find this number. So taking the new power multiplied by the derivative of the inside, and then we know we need to multiply that by something in order to get the number that we had here, which is x in this scenario. So we're left with 10x, which is 5 multiplied by 10x, multiplied by something in order to get an x, gives us 1/10. So f equals 1/10 multiplied by x squared plus 3 to the power of 5, and then 2 and 1. So now we're just gonna do f of 2 minus f of 1. So we're gonna have 1/10 multiplied by 2 to the power of 2 plus 3 to the power of 5. All of that is minus 1/10 multiplied by 1 to the power of 2 plus 3 and that to the power of 5. Okay, which will give us 1/10 multiplied by 4 plus 3 to the power of 5. And that's going to be minus 1/10 multiplied by 1 plus 3 to the power of 5, which equals 1/10 multiplied by 7 to the power of 5 minus 1/10 multiplied by 4 to the power of 5, which equals 1/10 multiplied by 1600, 807 minus 1/10 multiplied by 1024 equals 16. Equals 1680.7 minus 102.4, which results in 1578.3. So it is very important to first anti-differentiate and then to plug in the numbers that we got into the function. Make sure that we substitute, we put the bigger number first, the upper one, minus the lower one, the f that we plugged in the lower number, and eventually we're gonna get a number. So it is very important to work on that, be familiar with the whole, make sure that we're subtracting the right functions, and you're gonna be good.